We are doing Verifying Trig Identities by Tinar and Wee Wee, or Whitney and Tina. We are doing Example 1, Episode 1, Number 5. The problem is secant squared theta minus tangent squared theta. If you look in your trig identities chart on page 458 in the book, there's a Pythagorean theorem identity, which is 1 plus tangent squared u equals secant squared u. And that can be arranged to fit this problem. When you rearrange this identity, you have 1 plus tangent squared u equals secant squared u. And subtract tangent squared u, which equals negative tangent u. And that equals 1, which is basically your problem. So the answer to this problem is 1.
For our second example, we're doing episode 2, number 5. The problem is cosecant y, cosine y, sine y. When you look at the problem, you see you have a problem with the cosecant. You have to rename things to get everything to sine and cosine. So when you look at the identities chart on page 458 in the book, you can rename cosecant y to 1 over sine y. And this is a reciprocal identity. Now you have, when you have all this and you simplify it, you're going to have 1 times cosine y sine y all over sine y. As you can see, you have a sine y on the top and the bottom, and because of that, you can cancel those out. And all you're left with is cosine y, which would be your answer.
Example 3, Episode 3, Number 18. The problem is cosine A, secant A, minus cosine A. You see you'll have to distribute the cosine A. When you do that, you have cosine A, secant A, minus cosine squared A. Since you should try to get everything to sine or cosine, you notice you have to use the reciprocal identity. We change secant A to 1 over cosine A using this identity. Now you have cosine A over top of cosine A. And when you have that, you can cancel those out, which you will just leave you with 1. Now you have 1 minus cosine squared A. When you rearrange the Pythagorean identity of this, Tina, what will you have?
Okay, you would use the identity of sine squared u plus cosine squared u equals 1. You would subtract cosine squared u from both sides, and when you do that, you would have sine squared u equals to 1 minus cosine squared u, which was what you got here, so you know that your answer is going to be sine squared a. Our example number 4 is from episode 4, number 10. The problem is sine cubed y plus sine y times cosine squared y. First, you have to factor out a sine y. So when you do that, you have sine y, and then in parentheses, sine squared y plus cosine squared y. When you look at the trig identities chart on page 458 in the book, you see that one of the identities allows you to rename sine squared y plus cosine squared y to 1, which we did. Now you have sine y times 1, which is basically the same thing as sine y, and that's your answer.
Alright, here we go again. We're doing Episode 5, Number 1. The problem is 1 minus cosine theta times 1 plus secant theta times cosine theta. First, you have to rename secant theta to 1 over cosine theta using a reciprocal identity. Now you have 1 minus cosine theta times 1 plus 1 over cosine theta times cosine theta. Now you have to make the fractions out of things, and you have to put the 1 subtract cosine theta and the cosine theta over 1. You have to find a common denominator for 1 plus 1 over cosine theta. And when you do that, you have cosine theta plus 1 over cosine theta. Now you have 1 subtract cosine theta times 1 plus cosine theta times cosine theta over cosine theta. You see that you have a cosine theta on the top and bottom, so they can be canceled out. You can also combine 1 minus cosine theta and 1 plus cosine theta. So you have 1 minus cosine theta squared. Now all you have to do is the 1 subtract cosine theta squared. Theta. When you rearrange one of the Pythagorean identities, you can rename 1 subtract cosine squared theta to sine squared theta.
Okay, this is our last example. This is episode 6, number 6. You have to prove that cosine x plus sine x times tangent x equals secant x. You have to pick one side and solve it to see if it equals the other side. So we renamed tangent x as sine over cosine x using a quotient identity. When you make fractions out of cosine x and sine x, you have cosine x over 1 plus sine x over 1 times sine x over cosine x. Now you multiply, and when you do that, you have cosine x over 1 plus sine squared x over cosine x. Now you need to find a common denominator. And when you do that, you find that cosine x is your common denominator. You can finish simplifying until you have cosine squared x plus sine squared x all over cosine x. Using a Pythagorean identity, you can rename cosine squared x plus sine squared x as 1. When you do that, you have 1 over cosine x, which, using a reciprocal identity, you can rename that as secant x, which proves that the problem is right.